Let's solve this MIT integration B problem. We have this function x to the power 1 over log of x. So whenever you have a function to the power function, just use substitution. Substitution should be your first thought. So if we plug here u of x as log of x, and x will become e to the power u, and d of x would be e to the power u du. So when you plug this substitution back into your function, this x is e to the power u, this x is e to the power u, and this 1 over log of x become 1 over u, and this u and u cancels out. And you have this eu du, and this e is basically a constant you can take out, and you have e to the power u du. This is very simple, and you have e times e to the power u plus c, and when you plug that in, you know the log property of you can exchange this e with this x, and you left with this answer. So when you exchange this x with e, log of e is basically 1, and you have this answer. So the trick here is whenever you have some function to the power function, your first thought should be substitution, and then you can simplify it. Okay, so let's do this MIT integration B problem of 2023. You have this hyperbolic function, and so whenever you have this hyperbolic function, if you know about hyperbolic function, like you can convert them. So one of the property of this function is that this is the inverse of 1 over cos x, and one thing about hyperbolic function you should remember, you can convert them into exponentials, and exponentials are quite easy to deal with if you don't know how to integrate hyperbolic functions. So let's plug that in, and now you have this function. And so one thing to remember about this function, whenever you have this kind of function, try to convert them into same power, and we are always like to deal with in positive power, so you can multiply and divide by e to the power x, and when you substitute that in, you left with e to the power 2x plus 1. So now you should see this as a u substitution. Very easy. If you take u to the power e of x, you get du e to the power x times d of x, and when you plug that substitution in, you have this simplification, because this e to the power 2x can be written as u square. So one thing to remember, whenever you have this function, this is the standard integration that you should remember how to do it, because you should remember some of the integration, because whenever you do an integration, the only exit point is to convert them into a standard integration, and this kind of integration comes very often, so you should remember that. I will make a video of standard integration that you should remember, and this is basically a inverse of tangent of x, and you have tangent of x, inverse tangent of u. Now you can plug back your u substitution, and you have this your answer. So whenever you have hyperbolic function, try to convert them into exponential. Sometimes if you know the integration of hyperbolic function, those are also easy. If you know, that is also fine, but if you don't know, try to convert them into exponential function, and it will make your life easy. So I will see you next time. So let's do MIT integration B problem 2023. So we have this horrible looking problem. Okay, so whenever you have a mixture of function, by mixture of function I mean you have e to the power x, and you have a logarithmic function. So you have two kind of function, exponential and logarithmic. Your mind should go into by either substitution or integration by parts. But whenever you have a log function and you see its argument in the denominator, that is your key to u substitution, because when I put u as my log of 1 plus e to the power x, when I differentiate it, I'm gonna get in the denominator the same argument whatever is in the log argument, and that is your key. And in this case you also have e to the power x, and that make your life more easy, because when I plug all my substitution back in, this become du over u, and this is the standard integration of log of x plus c, and then you plug back your substitution and you get this simple looking answer, not simple looking log of 1 plus e to the power x. So the trick here is, whenever you have a mixture of function, try to think of either integration by parts, or you have a substitution. So whenever you have a log in your question and you see the argument in the denominator, that is your key to use substitution. I hope you like this video. If you like, give me a thumbs up and share and subscribe. I will see you next time. Let's do MIT Integration B 2023 problem, and you have this series, multiplication of series, and this look horrible. Okay, so when you look at this problem, you will try to be smart, like, oh, there's something I can do to make it easy. Just go for it. These are really simple terms. They are just trying to scare you off with all these series. Just go for the algebra, because it's just multiplication and cancellation. Half of the thing I know it's gonna get cancelled, and that's exactly what happens. So when I open this up, and you can see this minus x cancel with this x square cancel with this x square, this x cube cancel with this x cube, and x4 cancel with this x4. So whenever you're doing this, just go for it. Don't try to act smart. So after you cancel all the terms, you're gonna left with these terms and these basic standard substitution, and you're gonna get this result. So whenever you have these kind of problems, don't try to be over smart. Just do the algebra. Don't be lazy. So I will see you next time. Like, share, and subscribe. So you have this summation of x, sine of x times cosine, and sine times cosine. So one way to think about it, you could separate them. So x is easy, sine of x, this is a standard result, x cosine x, you can use integration by parts because this is a mixture of function, and sine cosine you could use substitution, but that is very cumbersome. So one way to think about it is look at for like terms and try to take a common factor. So I see x here, I see x here. So I'm gonna take x as common here. I see sine of x and sine of x in these two terms. I'm gonna try to see the common things, right? And when I do that, I see x times 1 plus cosine of x, sine times 1 plus cosine of x. Now I see these two terms common, and I can see if I do that, x 1 plus cosine of x times x plus sine of x. So this whole term turn into this compact form, and you have this function. And now you can see, if I take this u as x plus sine as my substitution, you get du 1 plus cosine of 1 plus cosine of dx. And now you can substitute back your substitution, and this become very easy, u times du, and this is u square by 2 plus c. And now you can plug back your substitution and see how easy it become. So whenever you have so this problem is basically testing if you can manipulate the your terms and see you can come up with a better like a u substitution. So whenever you see common terms and these are kind of in addition, try to take a common factor. I will see you next time. Like, share, and subscribe. Okay, so MIT Integration B 2023 problem, you have all the trigonometric functions in just one question. If you hate trigonometric, this might be your nightmare, but just look at it. If you remember trigonometric identity, so what are basically goal in trigonometry is, whenever you have some kind of trigonometry, your end goal is to turn this integration into some standard result that you remember, and that is your exit point. And in this case, there are so many of this trigonometric function. One thing is to use identities and try to get into one or two forms so you can actually integrate it. And if you know the standard results, you can remember. So I know the standard result of secant of x and cosecant of x, so I'm going to try to convert everything into those two functions, but this comes by practice. Like, I don't know what kind of standard result you remember. I remember secant of x and cosecant of x, and I'm going to try to do that. So all the trigonometric identities here. So if I look at this, sine of square x plus cosine of square of x is 1. So this is 1. I can change my tangent of square x into cosecant square of x minus 1, cot square x cosecant square minus of x. And let's see what happens. So when I do that, this x minus cancel with this plus x. I know I get secant square x plus secant 2 secant square x, cosecant x 2 cosecant x, and minus 1. And this convert into this. I know the standard result of both of them. This is tangent of x and this is minus cot x. and this is just x, and I am gonna get plus c in the end. So your goal is to, whenever you see kind of trigonometric function, try to convert into one or two, whatever possible. I saw this problem, I knew I need to convert into standard result. When I try to simplify this, I could see I could convert into two trigonometric functions, and I know the standard result of secant x and cosecant x, and that's what I try to convert into. And you can see this simplifies, and I got my answer. So don't be scared of trigonometry. So I will see you next time. Like, share, and subscribe. Let's do MIT integration BRIC 2023 problem. This is a mixture of function. You have log of x, you have e to the power log of x whole square. So whenever you have a mixture of function, you have two things which you can try. One is substitution and other is integration by part. So if you try to do substitution, you can take this as u and try to see if it simplifies, or you can take this as your substitution and try to see it if simplifies, and you're gonna end up getting nothing simplify. So the other thing to fall on is your integration by part. So if I look at this first integration, I will choose this to differentiate, or either, because I don't know how to integrate this thing, e to the power log x whole square is not an integrable function analytically, so I need to use this as my differentiable, and I need to integrate this, and this is also looking horrifying. So what I'm gonna do, I'm gonna distribute the function and see if it simplifies a little bit. So what I'm gonna do, I'm just gonna use integration by part in this second one. So when I do that, I choose u as to differentiate e to the power log x whole square and dv as 1. And you differentiate, you get this horrible looking differential, and you integrate dv, you get v. So now you multiply u and v, which is x times log to the power e to the power log x whole square, and you multiply v times du, and integration of this, you get negative of this whole function. And now you see this and this cancels out, and only thing left is this. X times log e to the power log x square. So what is this even telling you? So whenever you have a mixture of function, you have either substitution, or you can do this, integration by part. So in integration by part, you need to keep in mind this is one type of problems that are usually being asked when they're asking for integration by. Let's solve this MIT integration BRIC 2023 problem. You have this polynomial which looks horrible, to be honest, but you do see a kind of pattern. This is a square b square c square minus 3abc, right? So you see some kind of power, like a to the power a plus b power, some kind of power is being used, and this is basically testing if you know some identity, and this is that identity. So if you expand this identity, you will get this whole expression, and this is not something you can think on at the moment. Like this is not something you can think at while doing the exam. You have to have exposure with this identity, how to use this. So now you have seen this identity, so you can use it. So if I plug back everything in, when I plug back a plus b plus c, all the things cancelled out and I get 0 as an answer. So this is basically testing if you know this identity, and if you know, you can solve this. Otherwise, if you try to expand it, use some kind of substitution, it's just not gonna work out. You need to know this identity to solve this problem. So I hope you like this video. If you do, give it a thumbs up. I will see you next time. So let's solve this MIT integration BRIC 2023 problem. You have a bunch of absolute functions bunched together. So one thought to solve this problem is I can't expand 2023 terms, right? I can't open this absolute function. It's gonna be a mess. So there's need to be a pattern. That's where your thought should go. You need to find a pattern to solve this problem. Okay, otherwise there is no way you can solve this problem. And whenever you have a definite integration, they are basically asking for area under a curve. You need to find a pattern. There's the definite integration. There is a coloration. You need to go into graph. So let's try to plot absolute function the first few terms. So what I'm plotting is, let's see. So the first thing I'm plotting is my absolute function. So when I subtract -1, I'm gonna get I need to shift the whole graph by -1. Now when I absolute that put absolute function around all that, I'm gonna take everything that is at the bottom, I'm gonna put it at the top like this, right? And when you do it again, like for the next -1, you're gonna get these two triangles. So now you're getting the pattern, right? You're just finding these triangles. So when you do it 2023 time, you're gonna get these 2023 triangles. Okay, and you can see the base of this triangle is 2 unit, height is 1 unit, and you are doing it from -2023 to 2023, which means in this range I'm gonna get exactly 2023 triangles, which is because the base is 2, so it's gonna cover the half of this range. So basically, if you calculate the area of one triangle, just multiply it with 2023, and the half time the height, which is 1, base 2, multiply with 2023, you get the answer 2023. So whenever you have these complicated looking functions, try to find pattern. And whenever you have definite integration, try to go into graphing. You're gonna find pattern over there. If they are mathematically very impossible to solve, you need one thought should go into looking into graphs. There is no way I'm gonna open this every absolute function. It's gonna be a nightmare. Okay, so I hope you like this video. If you like, give the thumbs up, subscribe, like, share. So I will see you next time. Let's solve this MIT integration B 2023 problem. You have sine to the power 6x, cos to the power 6x, and 3 times sine square x, cos square x, dfx. So when I'm seeing this function, it's instantly reminding me of this identity, because if I take sine square to the power cube, cos to the power cube, 3 times this function, because sine square and cos square become 1. So when I plug that sine square and cos square to the power 3, I get, so this sine square plus cos square, 1, and I get this function back, and basically this is basically 1. So this whole thing just turn into 1, and you get x plus c. So this is a very simple problem. I hope you like this video. If you do, give the thumbs up, share, and I will see you next time, and subscribe. Let's solve this MIT integration problem 2023. You have this function x plus e plus 1 e to the power x to the power e to the power x d of x. So whenever you have this kind of whenever you have e to the power x, this is a mixture of function again. If you have seen my previous videos, this is the mixture of function. You need either a substitution or it's integration by parts. Substitution would not work. I tried it and I couldn't really work with it. So the next thing to follow is on integration by part. But there is some general answer that you can do it easily. What I'm gonna do, I'm gonna distribute e to the power x to the power e inside, and what I'm gonna get is this function. And this is a very common type of question you will get. So what I'm saying is, whenever you have, this is the general type of integration. So whenever you have a function and you multiply with that the derivative of that function times e of x, this is what the answer should be. And this is exactly this type of question. My function is x to the power e plus 1, and its derivative is basically plus 1 x to the power e. So my answer is x to the power e plus 1 times e to the power x. So keep in mind, this is a competition. They do expect you to know all these kind of tricks beforehand rather than solving it on the go. So, and to prove this, I will leave it as a homework. Basically, you're gonna use integration by parts. What you're gonna do is you're gonna distribute e to the power x on both sides, and you're gonna use integration part on the second one, where derivative of x, f of x times e of x, and this is gonna cancel out, and you're gonna left with e to the power x e of x. That is the general proof. I didn't prove it. I gave you the answer, but if you wanna do it on your pen, take a pen or pencil and do it on your notebook, and you will see the proof of this identity. So I hope you like this video. If you do, give it a thumbs up, and I will see you next time. Let's solve this MIT integration B 2023 problem. You have this polynomial which looks horrible, to be honest, but you do see a kind of pattern. This is a square b square c square minus 3abc, right? So you see some kind of power, like a to the power a plus b power, some kind of power is being used, and this is basically testing if you know some identity, and this is that identity. So if you expand this identity, you will get this whole expression, and this is not something you can think on at the moment. Like this is not something you can think at while doing the exam. You have to have exposure with this identity, how to use this. So now you have seen this identity, so you can use it. So if I plug back everything in, when I plug back a plus b plus c, all the things cancelled out and I get 0 as an answer. So this is basically testing if you know this identity, and if you know, you can solve this. Otherwise, if you try to expand it, use some kind of substitution, it's just not gonna work out. You need to know this identity to solve this problem. So I hope you like this video. If you do, give it a thumbs up. I will see you next time. So let's do this MIT integration 2023 problem, and you have this combination function. So whenever you have combination function, expand it and see how the expression become. You have x factorial divided by x minus 5 factorial, and you get this list of x that you multiply together, and you have this 0 to 4x, x minus 1, x minus 2, x minus 3, x minus 4 dx. So how do we can do this? One thing you might think of is to simplify this, because this is a polynomial and you're gonna get single term, and you can then use the standard integration of x to the power n, but that is gonna take so much time. So here is the trick. So whenever you have a definite integration, you should always make use of this trick. So one thing I want to do, I know this is from 0 to 4. If I can make it like symmetric from like negative 1 to 1, negative 2 to 2, negative 3 to 3, then I might have a chance of simplifying this expression. So what I mean by that is, when I take u is equal to x minus 2, du become dx, and my lower limit become negative 2, upper limit become 2. So this is a symmetric limit, and whenever I have a symmetric limit in definite integration, I need to check. This is a must. You need to check if it's an even function or it's an odd function. If it's an even function, it become 2 times 0 to 2, whatever the function was. But if it's an odd function, your work becomes so easy. The integration becomes 0. This has to do something with the symmetry of the graphs, so which we can talk later. But whenever you have a function that is going from like a symmetric limit, like negative 1 to 1, negative 2 to 2, so you need to check if it's an even or an odd function. If it's odd, then the answer is very simple, 0. And let's check our function. And when you check our function, it's odd function. So, and limit is going from -2 to 2, it's the odd function, so the answer is 0. So if you haven't seen this trick before, it's very important in definite integration, because some of the questions are just based on this problem. They give you really complicated function, and you just have to check if it's even or odd function, and if it's odd function, your answer become very easy. You get 0. So I hope you like this video. If you like, give it a thumbs up, subscribe, like and share. I'll see you next time. Let's solve this Emmet integration B 2023 problem. You have this integration, definite integration, and you have product sequence or series, whatever you call. So the first thing your thought is you need to simplify this expression, and then you can only solve it. So let's try to solve that expression. So when I expand this expression, I get 1 over 1 plus x when k is 0. 2 to the power 0, that is 1, so it's x plus 1, 1 plus x square, 1 plus x to the power 4. So now let's just look at this series and try to expand some of their terms. And when I try to expand this, I get 1 plus x square plus x cube. And then when I expand further, I get all this power 1 plus x square. So you get the pattern. This is a geometric series which is going to infinite. So when you want to try the sum of that is basically a, which is the first term, that is 1 minus r, which is the ratio is basically x. So when you plug that in, 1 over x, you get 1 minus x. And now you can integrate this with standard integration. So 1 would be x and minus x square over 2, and when you plug this value in, you get 1 over 2. Basically, whenever you have series, try to expand. Let's do Emmet integration B 2023 problem. You have this sine and with e of x. So whenever you have a mixture of function e to the power or sine of x, there is either substitution or either integration by part. Or when you try to do integration by part, I can't separate these two functions. Like, it's gonna be too cumbersome. Like, what should I do? Integrate? What should I differentiate? So it's gonna be a little difficult. But whenever you have these kind of questions, what I mean by that, this exact type of question, and this is exactly that type of question, there is a general way to find the substitution u. What you're gonna do, you're gonna take the numerator, that is sine of x, a times the denominator plus b times the derivative of the denominator plus c. In this case, our c is basically 0. So when I do that, I have sine of x, which is the numerator, a times the denominator, b times the derivative of the denominator. What I need to do is I need to find the coefficient of sine of x and coefficient of cos of x, coefficient of e to the power x. So the coefficient of sine is a minus b, that is equal to 1. And then the other coefficient you're gonna get, a plus b, is equal to 0. You can do either cos or you can do e to the power x. You're gonna get the same. So when you solve this problem, you get a to the power 1 over 2, b to the power negative 1 over 2. So basically, I can replace my numerator with this by replacing the value of a and replacing the value of b with minus half and a with half. I can replace this numerator with this substitution. So when I do that, this things cancelled out with this thing, so you basically get with e of x, and this is the derivative of this one, so you get log of x. So this is the answer. There is another trick where you multiply with 2 and divide by 2, but I feel like that is very unnatural. If you remember this kind of question, it's easier to do this way. This become more natural. Otherwise, to do the trick, I think you have to multiply and divide by 2, and then you're gonna try to exactly make this. You will exactly make these two substitutions. That is another way. You can try to do it and see if you get this exact answer. So like, share and subscribe. I will see you next time. Let's solve Emmet integration B 2023 problem. You have this definite integration and you have this polynomial. So if you look at this polynomial, it's reminding me of expansion of 1 plus x. So you have x to the power 5 but I see this and this and there is no 1, so I need to make this into this. So I need to subtract minus 2x square minus 4x minus 1, so you get this whole expansion. Now you have this expansion. This is much cleaner than this function, because if I try to use the standard substitution here and I plug in the values, it's gonna be too long and it's gonna take too much time. So I need to simplify in some way. And when I try to simplify further, I'm gonna add plus minus 1, because this negative 1 and this negative 1 is negative 2, and I can take 2 common, and this is basically x plus 1 and plus 1. So this whole thing turn into x plus 1 to the power 5 minus 2x plus 1 to the square plus 1. So now I have this much cleaner version of this polynomial. So what I can do next, I can take u substitution as x plus 1, lower limit become negative 1 over half, upper limit become 1 over half. This is symmetric limit, so I need to check if it's an odd function or it's an even function. So when I plug that in, I know u to the power 5 is the odd function, so this become 0. This is the even function, so this become 2 times, so I can write this negative 4. I did u to the power square over 3 over half to 0, and this u, I think here it should be negative half, not 0. And when you solve this problem, when you solve this, do this algebra, you're gonna get 5 over 6. But make sure here you put negative half. Like, share and subscribe. I will see you next time. Let's do MIT Integration B 2023 problem. You have 3 times sine 20x cos 23x plus 20 sine plus 20 sine 43x dx. I know this 43, I can write it as 20 plus 20x plus 23x, and now I can use my sine a plus b, and when you do that, basically that is sine a cos b cos a sine b, and this term add with this term become 23 sine 20x plus this become 23 sine 20x cos 23 plus 20 cos 20x times sine 23. So now when I look this problem, I know 23, I have 23 here, I have 20 here, I have 20 here. So you can see this derivative become basically this, and the answer becomes sine 20x sine 23. Let's do MIT Integration B 2023 problem. You have this horrible looking function. You have x to the power, a really big number. The one thing that should strike is to simplify the expression. Wherever you can take x common and see if I can cancel something. That is my game plan in this. So let's see. So what I can do here, I can make this as x to the power 22 plus x to the power 22, and I take common x from the denominator. This x and this x cancels out, and I left with x to the power 22 divided by x times 1 plus x to the power 22, and this x cancels out with 1 of this x. Okay, so this, in this term you just left with 1 over x dx, and in this term you left with, cancel this 1x with from x to the power 2022, you left with x to the power 2021 plus 1 divided by 1 plus x to the power 2022. Now you can see this easy substitution. If you take u as your substitution as 1 plus x to the power 2022, du become 2022 times x to the power 2021, and now you can see this, when you plug back your substitution, you basically get du power over u times 1 over 2022. And when I plug back everything in, I get this answer. So when I plug back my substitution, what is this, which is 1 plus x to the power 2022, I'll get this answer. You can further simplify with the properties of log function. You don't have to, but if you want, you can do it. So I hope you like this video. If you do, give the thumbs up, like, share and subscribe. I will see you next time. Okay, so let's do this MIT Integration B 2023 problem. You have a summation of these two functions. So one thing I will try to do is take a substitution. When I take a t square as my this substitution, and when I try to simplify this expression, I get x. So one thing you want to look at, this function resembles this function, right? It's just the variable is changed. Okay, so when I take the derivative of this, I get this function. So what is the upper limit become? 0. When I plug my x to be 0, I get t to be 0, upper limit when I put x to the 1, I get upper limit to be 1. So this whole derivative, this whole function is basically 4 times t square 2 minus t to the power square over 2 dt. And this function I can write it as x time derivative of this function, the first function. And this is the general expression, f of x plus x derivative of this function. So basically this function can be written as x time derivative of this function. And when you have this kind of expression, you can write that as x time. So the answer of that kind of integration is basically x time f of x. So remember, this is a competition, so they do expect you to know these kind of tricks. If you try to, so basically you can prove this expression by using integration by part. If you take integration of integration by part of this function, this gonna cancel out. You're gonna left with x time f of x. So, but that will take time. But if you're in a competition like this, they expect you to remember this. So we're gonna do the same. But you can prove this function. You can prove this whatever you call identity or something. Basically my f of x is basically x to the power cube 2 minus x square, and so which multiply with x become x cube to the divided by 2 minus x square, and this is from 1 to 0, and my answer is 1. So I hope you like this video. If you do, give it a thumbs up. Will like, share and subscribe. I will see you next time. Let's solve this MIT Integration Bee 2023 problem. You have this 0 to 2 pi, you have this greatest integer function, and which is also known as floor function, and you have a function 2023 sine of x d of x. So whenever you have a function like with piecewise function, what happen is the function become discontinuous, and so you have to find the discontinuity, and you have to find where the function is discontinuous, and you can then separate the integration at that point and integrate them separately. But the problem in this question is there are so many discontinuous, and why is that? So we need to start from the floor function of sine of x. This is the floor function of sine of x, and you see you have a discontinuous at this point and at this point. So you need to separate the integration over those points, and from the graph when you calculate the area you get negative pi. That is important. So if I do now 2 sine of x, I have a discontinuity here, I have discontinuity here, I have discontinuity here, and here. So whenever whenever you have this piecewise function, you need to find where the function is discontinuous, and you need to separate the integral. But in this case, whenever this is for 2 sine of x, when I calculate the area of this integral, it's negative pi. When I do 3 sine of x, it's negative pi. So the answer, you might have guessed, is negative pi. You could not have done this problem if it just given you on an exam and you never have dealt with this problem. If it is like sine of x, or if it's 2 sine of x, that seems reasonable, because you can find the discontinuity when this number is smaller. But when you have this 2023, it's impossible. So you need to have a exposure to this kind of problem, otherwise you wouldn't have just thought of this problem, and you wouldn't have solved this problem on an exam. And this seems like a unfair question, or maybe it's a fair, because if you have to deal with this kind of function, and if you know how to find if you know the pattern, you can just say it's negative pi, and this is for tan, and as you go the answer is negative pi. So this is, I don't know, this is surprising to me somehow. I found it very intriguing, like whatever number I put, I always get negative pi. I don't know, I haven't generalized it in an analytical way, I just used graphs. But the basic, I think if I try to do it analytically, which I don't have time, the thing I would do, like I would go from sine of x and see the pattern in discontinuities, and I believe those discontinuities would have some pattern that would allow me to go allow me for discontinuity that zero this many discontinuities, and I will still get negative pi. That is my guess. I haven't done it, but I feel like that could be the only thing that I can think of doing it without using graphs. Otherwise you can draw graphs, but even if you know how to draw graph, this would be too cumbersome when you're dealing with such a big number in front of a sine of x and greatest integer of x. So in short story, some of the question you see this, if you are any kind of integration competition, and if you see this kind of function and you see any kind of number here, just put negative pi. You don't have to explain it, but you can just put it there. But I hope you like this video. If you do, give it a thumbs up, like, share and subscribe. I will see you next time.